Welcome to Simultaneous Equations video 3, where we're going to talk about our first of the two algebraic methods, the elimination method. So I'm going to show you a few examples as we go through this. First one will be quite easy, and we'll build on to more difficult examples. In each case, you can always stop, pause, rewind, have a look again. I'll explain each part as I go, but I might do it quite quickly because you can stop and go back if you need to. So the first example is x plus 3y equals 5 and x plus y equals 3. The elimination method relies on you being able to eliminate one particular variable. In this case I have two variables, x and y, and I'm going to eliminate x. The way I'm going to do this is to denote each equation by giving it a name. I'll call it 1 and 2. You may call it anything you like. And I'm going to subtract equation 2 from equation 1. Now this might sound a little bit silly, but let's have a look at the result here. Just like you're doing a subtraction back when you were in primary school learning how to subtract normal numbers, 2, 3, 4-digit numbers, we're going to do the same thing. I'm going to look first of all at subtracting the x's. When I subtract x from x, I'm left with 0x. So if I've got 1x here and 1x there, I subtract 1x from the other x and I'm left with 0x's. Now I'm going to look at the y's. When I subtract y from 3y, I'm left with 2y. And then I'm going to look at the number. When I subtract 3 from 5, I'm left with 2. So as you can see here, 0x is 0, and we have 2y equals 2, which means when we divide by 2, we're left with y equals 1. Now to calculate our x coordinate, I simply have to substitute this y back into one of my equations. And substitution is going to be a really important component of what we do for the next two lessons. So I'm going to use substitution to substitute my y back into equation 1. Y equals 1 into, I end up with x plus 3 equals 5. And my y, remember, is equal to 1. So x plus 3 times y becomes x plus 3 times 1. So this is x plus 3 equals 5. I subtract 3 from both sides, and this is x equals 2. Example 2. This time, I'm going to show you a slightly different example. But I do urge you to stop the video now and maybe have a go at the example yourself. You might find that you can't finish the question, but you'll get a better understanding of what I'm about to talk about. So this time I'm going to do the same process from the start. Give the equations names so I can name them later on. 1 and 2. Then I'm going to add my two equations together, 1 plus 2. And the reason I'm going to do this is my x's actually look quite difficult to cancel out this time. But my y's, I have plus 4 and I have minus 4, which means that by adding the plus 4 and the minus 4 together, I'm back to 0y. I get 2x plus 5x is 7x. Here, my y's cancel out, so I'm actually not going to write that down this time because you don't need to. 0y is obviously nothing, and my numbers end up equaling 21. 7x equals 21, divide by 7, x equals 3. Now that I know what x is equal to, I substitute that back into equation number 1. It doesn't matter which equation you use, so 2 plus 4y equals 2, and remember x equals 3, so this will be 2 times 3 instead of 2 times x. And that now gives me 6 plus 4y equals 2, which gives me 4y equals negative 4. I've subtracted 6 from both sides of my equation, and it gives me y equals negative 1. I've divided by 4. And as you can see, there's my solution. Once you've completed the question, you may want to summarize by writing x equals 3 and y equals negative 1. I'll also add another note on now that it's always a good idea to then verify your solution by using the opposite equation that you used when you substituted in. So we used equation 1. I'm not going to use equation 2, which is 5x minus 4y equals 19. But I'm going to rub out the 19, and I'm going to show that it equals 19 by substituting in 5 minus 4. In red again, I'll write what this is equal to, which is 3, and 4 times negative 1. So that becomes 15, 5 times 3, minus negative 4, 4 times negative 1. And that's equal to 15 plus 4, which is equal to 19. And so we've actually verified our solution works in both equations. Welcome to example 3. So again, I'm going to denote them 1 and 2, but this time I don't have a really easy way of mapping out my x's and y's, because in neither case are the coefficients, that is the number in front of x or in front of y, the same in both equations. So I've got to find a way around this. And the way I'm going to do this is I'm going to get equation 1, multiply it by 3, and equation 2, and multiply that by 2. And the reason I'm doing that is it will turn both of my y values into 6's. Now remember, as long as I do the same thing to the entire equation, I'm not changing what the equation actually means. So I'm going to do this bit in blue. My resultant equations will be 9x minus 6y equals 21, and 10x plus 6y equals 36. And I'm going to call these new equations 3 and 4. Now I'm going to do equation 3 plus equation 4. And that will give me 19x, 0y equals 57. Divide by 19. And I get x equals 3. Now I'm going to substitute that back into one of my original equations, say equation 1. So into equation 1, x equals 3 into 1, and I get 3x minus 2y equals 7, gives me 3 minus 2y equals 7, where x is equal to 3. That gives me 9 minus 2y equals 7, gives me minus 2y equals negative 2. I subtracted 9 from both sides. I now divide by negative 2, y equals 1. So my solution is x equals 3 and y equals 1. And then I very quickly verify over here in equation 2. And equation 2 is 5x plus 3y equals 18. Well, 5x plus 3y in this case is equal to 5 times 3 plus 3 times 1. And that's equal to 15 plus 3, which equals 18 as expected. And this is example 4. 3x plus y equals 11. 2x plus 3y equals 10. Call this equation 1 and this equation 2. This time I'm going to multiply equation 1 by 3, which will give me 9x plus 3y equals 33. I'll call this equation 3, and then I'm going to subtract equation 2 from equation 3, remembering that 2 is 2x plus 3y equals 10. This gives me the matching 3y's. Now I'm going to do that subtraction, gives me 7x equals 23, and divide by 7, and I get x equals 23 over 7, or 3 2/7, but I'll be leaving it as 23 over 7. Now I'm going to substitute this into equation number 1. And equation number 1 you recall is 3x plus y equals 11. So I get 3 plus y equals 11. I put what my x is equal to, which is 23 over 7. And this gives me 69 over 7 plus y is equal to 11. Y is equal to, and I'm subtracting 69 over 7 away here. Remember, you'll have a calculator, but for my part I know 69 over 7 is 9 6/7. Taking that away from 11 leaves me 1 1/7, or 8/7. So my answer is x equals 3 2/7 and y equals 1 1/7. and then I always verify into equation 2. Scooching back up, equation 2 is 2x plus 3y equals 10. So let's try that. 2x plus 3y is equal to 2 plus 3, 2 times 23 over 7, 3 times 8 over 7. We'll have our fingers crossed here that this is correct. 46 over 7 plus 24 over 7, which equals 70 over 7, which equals 10, as expected. I hope that's helped you understand simultaneous equations by elimination method. Join me next time for simultaneous equations by substitution method. Thanks for listening.